Hello everybody, welcome to my class. Let's do a problem from grade 10 extended mathematics. So the today's topic is conditional trigonometric identity problem. So identity means here we are using this sort of trigonometrical identities. So here it is given that means if a plus b plus c equal to pi radian or 180 degree, then in that case you have to prove that cos square a plus cos square b plus cos square c plus 2 cos a cos b cos c equals to 1 under the given condition a plus b plus c. Therefore this is called the conditional trigonometric identities problem. And in order to start the solution, you can check here. It is given that a plus b plus c equal to 180 degree. If you are taking the sum of the angles in degree here, all the angles. So what sort of benefit you will have by given condition is that, so here if needed you can write in place of a plus b equals to 180 degrees minus angle c, or also as needed you can write here like for example, so if you transpose a plus b towards another side, so c equals to here 180 degrees minus a plus b angle together as you need. So you can replace the angles under the given conditions as needed. So let's start to the proof area here. So we have here this sort of thing in the LHS, and in the RHS you have to prove this as 1. So here let's start from here. So you should have, before you go through this sort of the problem, you should have knowledge of this sort of formula. Alright. So in this formula you know that sin c plus sin d equal to 2 sin c plus d cos c minus d. Sin c minus sin d is like that. Cos c plus cos d both cos, and cos c minus cos d means both sin. And then this way you have to understand the formula first. And then you have cos square a equal to 1 plus cos 2a by 2. And also if needed in another problem, other kind of problem in the related to the same. And then you have to also understand those trigonometrical identities formula. So here firstly I am taking these two terms. You can also take cos square b and cos square c term. Anyway you have to arrive to the result. So here in this case what I am writing here, that cos square means it is 1 plus cos 2a by 2, and cos square b, if I am using this, so it is 1 plus cos 2a by 2, and then plus it is cos square c, and this is 2 cos a cos b and cos c over here. Okay. Now furthermore here you can see that this is 1 by 2. So you yes, you can write here 1 by 2 plus 1 by 2 cos 2a. Okay, so if you separate the fraction, and here it is 1 by 2 plus 1 by 2, this should be cos 2b. Alright, and then we have term, this is cos square of c, and then plus, just you copy this. Alright, in exam you don't write copy like this I did here, because I do not have a space here, but you have to continue this term also. So here in this case you can now see 1 by 2 plus 1 by 2 is actually 1, and then plus you can take half common. So you have here cos 2a plus cos 2b over here, and then plus you have cos square c, and then keep copying the same. And next we have, if you go further, this is 1 plus 1 by 2. Now let's check here, this is cos 2a and cos 2b, and you can see the formula like cos c plus cos d. So in place of 2a you suppose as c, and 2b you suppose as d. In that case you can write 2 cos c plus d by 2 cos times 2 cos c minus d by 2. So I am taking here 2a as c and 2b as d and applying this formula. In fact no, this formula, because there is plus, So what you can write here is that this is 2 cos c plus d means 2a plus 2b by 2, and then you have again cos, yes, again cos, uh, 2a minus c minus d means 2a minus 2b by 2. Alright, and then you are left with here c, cos square c, and then plus you have to copy this term, and 2 and 2 they got cancelled out, so it is 1 plus it is cos. Now if you take out 2 common, then there will be a plus b, and 2 and 2 divided each other, they cancel each other, so it is cos a plus b, and then it is cos a minus b, and then plus you have cos square c, and then you have to keep copying that. All right, and now let's check here. Here we used, yes, we have now a plus b term. So in place of a plus b, what you can write here, you can write 180 minus c. So 180 minus c means you have, for example, this is the cos a plus b over here. So you can see here a plus b is 180 minus c. So what you can write here, cos 180 minus c, or 180 degree minus c. And you know that 180 minus c means cos is falling in the second quadrant where cos is negative. So here now this means it is, and cos remains cos. So there is cos c. So what you can write in place of cos a plus b is that, if you go ahead, it is 1 plus, you can check here, like it is negative cos c. So it is negative cos c, and then you are left with the term cos a minus b, and then plus you still have cos square c, and then you keep copying this term. Okay, and now what you can do, this is 1, and you take minus common, so minus cos c common, so you can write here minus cos c common. If you take, then what are we left with here, it is cos a minus b, and then you are left with here cos c only, and then plus it is, you have to copy this term, you have to keep copying this term. All right, and yes, and this is 1 minus cos c, and now it is cos a minus b, and then plus. Now let's check it again. So once you check that again, that means we are talking of c. So you can see here that c equal to 180 minus a plus b. Okay, so therefore here you can see regarding this terms cos c. So it is cos c if you have. So what you can write here, cos of 180 minus c. No, 180 minus here a plus b. A plus b. Okay, and this is again cos 180 minus theta. So it will be, there will be a cos itself, but as this is in the second quadrant, so this will be the negative cos of the given angle here, a plus b. Okay, so what you can write here, in place of cos c, you can write here cos a plus b, and then you copy rest of the term. So what we are continue to copy this here, 2 cos a, cos b, and cos c. Now after that, this is 1 minus cos c. Alright, now again you can use the formula cos c plus cos d. So cos c plus cos d means it was here the same formula that we have used over here, that is c plus d by 2 times cos c minus d by 2. So if you do so, what you will have here is, this is again you have 2 cos a minus b plus a plus b divided by 2, and then times you have cos a minus b, and as you are using minus sign, so it is minus A, and minus times plus is negative times positive is negative here, B divided by 2, and you have kept this continuing like that. Okay, so now let's see here. So after you continue from this this term, you will have, like here, this is B and this is plus, okay, and this is 2. So if you continue from here, it is now 1 minus cos C is already here, and inside the bracket you have here 2 cos, you can check here now, look at here, it is negative B and positive B, they got cancelled out, so 2A, A plus A is 2A by 2 is 2 and 2 cancel out, so this is cos A. So what you have actually, this is cos A. And in this term, what you can see actually, positive A and negative A, they got cancelled out. So it is now, you are left with cos of negative 2B. But 2 in the denominator cancels the 2 in the numerator, so that it will be there negative B only. Okay, and the term that we had been continuing was, it is 2 cos A, cos B and cos C. And now you know that, yes, since cos minus theta equals to cos theta, so there will be no sign change for cos minus B. So after that, if you continue, so it is 1 minus 2 is here, so 2, and then you have you can write here cos A. And one thing we are missing out from here, so in the beginning we had cos C, so we have to consider this cos C also. So first of all, we had cos A, cos B, and cos B times cos C. So because cos C is continued from here, so cos C also multiplies inside this bracket. Okay, and then you have here, it is 2 cos A cos B times cos C. So let's check here now, this is negative of 2 cos A cos B cos C, and this is positive 2 cos A cos B cos C. So they cancel each other. Alright, so what are we left with here is 1, and which is RHS, and hence this is proved. Okay guys, hope solving this problem will boost up your knowledge and skill in solving trigonometric problems like this. Thank you so very much for watching.